All right, welcome back everybody. For those of you that weren't here previously, we are just kicking off the second hour of Operator Math 1 and 2. Again, my name is Jadon Herron. I'm an engineer with Anderson Perry & Associates out of La Grande. I've been with Anderson Perry for just over 7 years now. I grew up in a little town called Union here in Eastern Oregon. Went to college at Eastern Oregon University and then finished off with a degree from Oregon State in civil engineering. So in the first hour, we did a review of some basic math concepts and then worked through some typical problems that you might encounter as a water or wastewater system operator. So now as we roll into the second hour, we're going to dive into some more basic math concepts, get some practice with calculating areas and volumes. We're going to look at some algebra, order of operations, and then work through a handful of practice problems. This next hour should be fairly straightforward, and then we'll kick off the third hour getting into some more example problems that are more likely what you guys will see in your day-to-day work as operators. Okay, the first set of problems we're going to work on today are going to be circumference and area of circles. Now, feel free to get some scratch paper, a calculator, pen, and work through these with me as we go along. So, first one we're going to do is number 1. So, find the area of the circle with a radius of 12 inches. So, again, I'm going to flip back. We're going to look at our formula and conversion table. And area of a circle, there's two ways we can do this. It's going to be either 3.14 times the radius squared, or also pi times radius squared, or we can use 0.785 times diameter squared. Throughout today, I'm going to just go ahead and use area of a circle of 0.785 times diameter squared to be consistent. So we have area is equal to 0.785 times diameter squared. This is going to be, we know diameter is 2 times our radius. Our radius is 12 inches, and that's going to be squared. So going back to order of operations that we touched on in the last hour, first thing I want to do is everything in the parentheses. So 2 times 12 is going to be 24 inches squared. So 24 squared times 0.785. This is going to get us 452.2 inches squared. And again, we're going to be tracking our units through all these problems. Next problem we're going to work on is problem number 5. So again, same equation. Area is equal to 0.785 diameter squared. And we know our radius is 2.6. So as we go through order of operations, we'll do 2 times 2.6. We'll take that answer, we're going to square that, and then multiply it by 0.785. And we should come up with a 21.2 inches squared. All right, let's move on down and take a look at problem number 9. Find the circumference of each circle. Use your calculator's value for pi, round your ounce answer to the nearest tenth. So let's take a look at our equation sheet to figure out what it talks about for the circumference of each circle. So circumference of a circle is going to be equal to 3.14 times diameter. So if you go back to this question, it says use your calculator's value for pi. So when we see the equation of 3.14, this is actually a rounded number. This is pi, which continues on for multiple decimals past this. But for what we'll be working on, we can go ahead and round pi to 3.14. But if you see in a question like this, you can definitely use your calculator's value for pi and get a little more precise number. So again, let's go ahead and work this out. It's going to be 3.14 times diameter, which we know our radius is 8 miles. So our diameter is going to be 2 times that. And this is going to give us a circumference of 50.2 miles. So let's jump on down here and take a look at question number 17. Find the radius of each circle. Use your calculator's value of pi, round your answer to the nearest tenth. So again, we're not going to worry about using pi. We'll just go ahead and use the equation that is included in our cheat sheet here. That circumference is equal to 3.14 times our diameter. So let's go ahead and write that equation out. Circumference is equal to 3.14 times our diameter. So we know our circumference is equal to 62.8 miles. That's going to equal 3.14 times diameter. So what we want to do is divide both sides of this equation by 3.14 to solve for D. 62.8 miles times 1 over 3.14. So again, 3.14 is a constant here. We don't have to worry about units with it. So I went ahead and wrote this out. We could do this really quickly with our calculators, but I wanted to show you guys this math process again. So I'm dividing both sides by 3.14. So 62.8 miles divided by 3.14. I'm showing it as times 1 over 3.14. I'm breaking this out because as we work on more complicated problems in the next hour or so, you'll see that we're going to be tracking units, and this is a very clear way to keep track of everything. So we get 62.8 divided by 3.14 is equal to 20 miles. On our right side of the equation, 3.14 is going to cancel with 3.14, and we're just going to get our diameter. Now if we go back to the question, number 17, says find the radius, and again we know that our radius is half of our diameter, so our radius is going to be equal to 10 miles. All right, let's take a look at question number 21 here. Find the diameter of each circle. Use your calculator's value of pi. Round your answers to the nearest tenth. So in this case, it's giving us our area to start with. So going back to our cheat sheet, we have area of a circle, 0.785 times diameter squared. So we know our area of 201.1 inches squared is equal to 0.785 times our diameter squared. So again, I'm going to write this out. We're going to divide both sides of this equation by 0.785 in order to isolate our variable d. So we have 201.1 inches squared divided by 0.785. This is going to give us an answer of 256.18 inches squared on the left side of our equation. On the right side of our equation, the 0.785 is going to cancel, and we're left with just diameter squared. So the next step of this process is going to try and isolate d. So again, we want to take the square root of both sides of the equation. So when we square root of 256.18, we get 16 inches. So inches squared, square root of that's going to be just straight inches. And the square root of d squared will just be d. So our diameter is 16 inches. All right, let's jump on down here to question number 27. Find the radius of a circle so that its area and circumference have the same value. All right, so what do we know? We're trying to find the radius of a circle so that its circumference and its area have the same value. So we've been working with two equations. We have our area is equal to 0.785 times diameter squared. And we know that circumference is equal to 3.14 times diameter. Now the question is asking for us to solve for our radius so that the area and circumference are the same value. So we want area to equal our circumference. Well, we know area is equal to 0.785 d squared and circumference is equal to 3.14 d squared. And we know that area and the circumference have to equal one another. So we know then that 0.785 times our diameter squared has to equal 3.14 times our diameter. So now what we want to try and do is we have to isolate our d and try and get both of them on the same side of the equation. So what I'm going to do is I'm going to divide both sides of this equation by 3.14 d. Okay, so when we take the left side of our equation, we'll take 0.785 and divide it by 3.14. So we get 0.25. Now we have a d squared divided by a d. So again, like we talked about in the last hour, this d on the bottom is actually raised to the 1 power. So when we divide by exponents, we actually subtract. So d squared divided by d to the 1 is going to be 2 minus 1 is just going to be a d. Another way to think about it is just d squared divided by d. You're going to have 1d left. Now on the right side of the equation, we have 3.14d divided by 3.14d. So these are going to cancel each other out, and we're just going to have it equal to 1. So now we still have to isolate our d. So I'm going to multiply both sides of this equation by 0.25. Excuse me, I'm going to divide both sides of this equation by 0.25. So we get our 0.25 cancels our 0.25. 1 divided by 0.25 is going to equal 4. So this is going to go to d equals 4. Now going back to our original question, it asks find the radius. We know our radius is half of our diameter, so r is equal to 2. So if you guys have a calculator, you could run through this a lot faster, but I wanted to break it out and show you how we're going to be tracking units for future problems. Okay, the next concept we're going to touch base on again is the order of operations. So again, this was one of the concepts we talked about in the first hour, but we're going to go through and break it down a little more clearly. So order of operations, if you remember last time, this is PEMDAS. Which stands for parentheses. Exponents, multiplication, division, if I can write here, guys, bear with me, addition, and subtraction. Wow. As you can tell, us engineers, we are better with math than we are with writing and spelling. The other way we can remember PEMDAS is please excuse my dear Aunt Sally. So let's run through a couple of these problems really quick. I'm sure most of you guys already have a good grasp on this. But let's look at problem number 1. 3 times, in parentheses, 6 plus 7. So going back to order of operations, start with parentheses. So it's going to be, we'll do 6 plus 7 first. So this is going to be equal to 3 times 6 plus 7, which is 13. So done parentheses, so our next order is going to be the multiplication. So 3 times 13 is equal to 39. Problem number 2, 5 times 3 times 2. This is all straightforward multiplication. So let's do 5 times 3 first. So 5 times 3 is going to be equal to 15 times 2 is going to be equal to 30. Let's look at problem number 3. We have 72 divided by 9 plus 7. So we'll do our division first. So that'll be 72 divided by 9 is equal to 8. So we'll have 8 plus 7. 8 plus 7 is equal to 15. All right, let's jump over to problem number 4. 2 plus 7 times 5. So we'll do our multiplication first. 7 times 5 is equal to 35. We'll do our addition next. 2 plus 35 is equal to 37. Let's jump on down here to problem 9. Let's keep moving on this. So this one looks a little more fun. We've got 20 divided by, in parentheses, 4 minus, parentheses, 10 minus 8. So we'll start with our inside parentheses first. So this is going to be equal to 20 divided by, so we have 10 minus 8 is equal to 2. So then we'll do the next set of parentheses next. So 4 minus 2 is equal to 2. So we get 20 divided by 2, which is equal to 10. Let's jump over to problem number 10. Here we have 40 divided by 4 minus parentheses 5 minus 3. So going back to PEMDAS, parentheses first, 5 minus 3 is equal to 2. So we still have 40 divided by 4 minus 2. So we don't have any exponents, so we'll go with our multiplication and division next. 40 divided by 4 is equal to 10 minus 2. Then 10 minus 2 is equal to 8. All right, let's jump down to problem number 17. So 17 is 43 minus 1 divided by 4 plus 2 plus 10. So now when we look at this, it might be a little bit confusing because you're supposed to do parentheses first, then exponents, then multiplication and division. But we're looking at this, we have 43 minus 1 divided by 4 plus 2. You're supposed to do your division first, but how do you really do your division first? So let's write this out so it's a little bit more clear for us to understand. So instead of saying 43 minus 1 divided by 4 plus 2, let's write it out like this. We have 43 minus 1 divided by 4 plus 2 plus 10. So the way I've written this here is the same way they have it written over on this problem number 17. This just shows the concept of PEMDAS a little bit more clearly. They both equal the same thing. So we'll start with our parentheses first. 43 minus 1 is 42. Divided by our next set of parentheses, 4 plus 2, which is equal to 6. And we have a plus 10. So next we'll do our division. So 42 divided by 6 is equal to 7. We still have the plus 10. So 10 plus 7 is equal to 17. All right, let's jump on down here to 25. So 25, we've got parentheses, 2 plus 6 times 2 plus 2 minus 4 times 2. So the first thing we're going to do is everything within our parentheses. Now we have multiple operations within our parentheses, so we'll go ahead and follow the order of operations within there as well. So first thing we'll do is going to be the multiplication within the parentheses. So 6 times 2 is going to be 12. Next, we'll do all of our addition within the parentheses. So 2 plus 12 plus 2 minus 4. This is going to give us 12 times 2. 12 times 2 is equal to 24. So again, we did everything within the parentheses first. Once we start working within the parentheses, we follow the order of operations again, and then did our multiplication very last to get 24. Okay, the next thing we're going to work on is going to be evaluating expressions. So the question says, evaluate each using the values given. So we'll look at problem number 1. The expression is y divided by 2 plus x. I want to use x equals 1 and y equals 2. So the first thing we're going to do is just plug in the values for each of these. So y is going to be equal to 2 divided by 2 plus x, where x is 1. So we get 2 divided by 2 is equal to 1. 1 plus 1 is equal to 2. So just plug and chug is all we're doing here, is we're plugging in the values and then running through our order of operations. Alright, let's jump on down here to problem number 7. So for number 7 we have z times in parentheses x plus y. So the first thing let's do is plug in all of our values. Z is equal to 6, x is equal to 6, and y is equal to 8. Plug them in, we get the expression 6 times 6 plus 8. So we'll do parentheses first. 6 plus 8 is equal to 14. Multiplication next. 6 times 14 is equal to 84. Again, we're just doing plug and chug. Alright, let's jump on down here to problem number 11. Problem number 11 is p squared times m divided by 4. So again, first thing I'm going to do is just plug in the numbers. So p is equal to 7. 7 squared times m, which is equal to 4. Then we're going to divide by 4. So we'll do our exponents first. 7 squared is equal to 49. 49 times 4 divided by 4. So 4 divided by 4 is just equal to 1. So we get 49 times 1, which is just equal to 49. So exponents first, went ahead and did our division next, and then finally our multiplication. Again, just did a plug and chug on this. Let's jump down here and take a look at problem number 15. So 15, p minus 9 minus m plus q. So p is equal to 5 minus in parentheses 9 minus m is equal to 4, plus q is equal to 3. So we'll do our inside parentheses first. 4 plus 3 is equal to 7. So then we get 9 minus 7. So 9 minus 7 is equal to 2. We get a 5 minus 2, which is equal to 3. All right. Now let's jump into using the distributive property. So the distributive property states it allows you to multiply a sum by multiplying each addend separately and then add the products. So that sounds really confusing, but in practice it's extremely straightforward. Let's look at problem number 1, and I think it'll make a lot more sense for you guys. So problem number 1 is minus 1. Oh, excuse me. Let's back up a little bit here. Problem number 1 is minus 6 times in parentheses a plus 8. So usually you do in your parentheses first, which would just be a plus 8. You'd take that and multiply it by 6. But in this case, you can't combine the a and the 8. So what we're going to do is the distributive property. So we're going to take minus 6 times A, and we're going to add that to minus 6 times 8. So minus 6 times A would be minus 6A. Minus 6 times 8 is minus 48. And that's the distributive property. So now this would be a good time to talk about multiplication of negative numbers. So when you have a negative number times a positive number, you get a negative number, and you get a negative number times a negative number, you get a positive number. It's just the way it is. Just remember that, and we'll work on that as we run through here. So let's jump on down and take a look at problem number 5. So 5 is minus 4 minus 3n times minus 8. So again, we're going to do minus 8 times our minus 4. We're going to do minus 8 times our minus 3n. So negative 8 times negative 4 is going to be a positive 32. And then we get a negative 8 times a negative 3n is going to be a positive 24n. All right, let's jump on down here and take a look at number 7. Number 7 is 1 minus 7n times 5. So we'll go 5 times 1 is equal to 5. Then 5 times minus 7n is going to be a minus 35n. Again, a positive times a negative is going to be a negative number. Pretty straightforward. It comes in pretty handy as we're evaluating expressions in the future. Okay, the next concept we're going to cover is going to be simplifying each expression. So it's pretty straightforward. Let's go ahead and dive into problem number 1. Minus 6k plus 7k. Minus 6 plus 7 is going to be equal to 1k. Let's look at problem number 3. N minus 10 plus 9n minus 3. Now if we want to, we can rearrange this expression to make it a little bit more clear. So we can go 9n plus n minus 10 minus 3. All I did here was rearranged all the variables. So I have my n's together and I have my numbers together. So 9n plus n is going to be 10n. Then minus 10 minus 3 is going to be a minus 13. So 10n minus 13. Let's take a look at number 5. Minus r minus 10r is going to be a minus 11r. Pretty straightforward, just combining the like terms. Let's jump down here and take a look at problem number 21. This one gets a little bit more interesting. So this one we have a minus 4 plus 7 times 1 minus 3m. So the first thing we're going to do is our distributive property. So we're going to do 7 times 1 and 7 times minus 3m. So we get minus 3 plus a 7 times a 1 is going to be 7. And then a 7 times a minus 3m is going to be minus 21m. So minus 4 plus 7 is going to be 3 minus 21m. So first thing we did was our distributive property, 7 times 1, 7 times minus 3m, and then we combined like terms to get 3 minus 21m. All right, let's jump down here and take a look at problem number 27. This one's getting a little more interesting again as well. So number 27 is minus 10 times in parentheses 1 minus 9x plus 6 times x minus 10. So again, we're just going to use our distributive property. So we get negative 10 times 1 is minus 10. Negative 10 times minus 9x is going to be a positive 90x. Then we get, again, distributive property on the right side. 6 times x is going to be 6x. 6 times a minus 10 is going to be a minus 60. So again, we can reorder this to make it a little bit more clear. So we can say minus 10 minus 60 plus 90x plus 6x. Again, all I did was combine the like terms next to one another. And then we can go through and do our addition of like terms. So minus 10 minus 60 is going to give us a minus 70. And then we get a 90x plus 6x is going to be a 96x. So again, we did the distributive property, then we just ordered it to have like terms, and then combined all like terms together. All right, let's jump down here and take a look at the percent change. So find each percent change to the nearest percent. State if it is an increase or a decrease. So we're talking about percent change. This is going to be really similar to percent removal. So if we look over at our cheat sheet again, and we get removal is in minus out divided by in times 100%. So let's take a look at this percent change. So we have from 45 to 92. So how much did this change? 92 minus 45 is going to be how much we changed. This is equal to 47. So then to find percent change, we're going to take how much we changed to 47 over our starting amount of 45. We're going to multiply that by 100% to get our answer in percent. And this is going to give us 104%. Now the question asks, state if it is an increase or a decrease. We went from 45 to 92. So it's going to be a 104% increase. Let's jump down and take a look at another one of these. Let's go to number 5. From 94 miles to 34 miles. So we started at 94. We went to 34. Which is going to be a change of 60. So we changed 60. We started at 94. Times that by 100% to get our answer in percent. 60 divided by 94 times 100 is going to be a 64%. We started at 94 and we went to 34. So this is going to be a 64% decrease. So those are pretty straightforward. Let's jump on down into our next section here. So next one is one-step equations, and we're going to solve for each equation. So let's take a look at number 1. So when it says solve for each equation, what we want to do is we want to isolate the variable on one side of the equation by itself. So we have number 1 is 26 is equal to 8 plus v. So what we want to do here is we want to subtract 8 from either side to get v by itself. So we're going to subtract 8 from the left side, subtract 8 from the right side. So we get 26 minus 8 is equal to 18. 8 minus 8 is going to be 0. So we just get 18 is equal to v. So the whole goal here is to isolate the variable to get it by itself. Whatever we do to one side of the equation, we have to do to the other side of the equation. Let's take a look at number 3. Number 3 states 15 plus b is equal to 23. So again, we want to isolate b. So we're going to subtract 15 from the left side of the equation. We're going to subtract 15 from the right side of the equation. And we get b is equal to 8. Let's take a look at number 5. Number 5 is m plus 4 is equal to negative 12. We will subtract 4 from both sides of the equation to isolate m. So m plus 4 minus 4, we get m is equal to minus 16. Take a look at problem number 7. So 7 is m minus 9 is equal to minus 13. We'll add 9 to both sides of the equation. So then we get m is equal to 4. Let's jump down and take a look at problem number 15. So for 15, we get v divided by 8 is equal to 2. We'll multiply both sides of this equation by 8. So similar to how we were writing these out previously, we'll multiply by 8 is equal to 2 times 8. So what we do to one side of the equation, we'll do to the other side of the equation. And we get v is equal to 16. Now let's take a look at problem number 17. 17 states minus 15x is equal to 0. So let's divide both sides by negative 15. So get minus 15x times 1 over minus 15 is equal to 0 times 1 over minus 15. You'll have to excuse my x's and my multiplications. These would be multiplication signs. So minus 15 divided by 15 cancels out. This leaves us with x is equal to 0 divided by negative 15. 0 divided by negative 15 is just equal to 0. So x equals 0. Now let's jump into something a little bit more fun. Let's look at some two-step equations. So number 1, 6 is equal to a over 4 plus 2. So again, we want to isolate the a. We have to do the same thing to both sides of the equation. So we'll subtract 2 from the right, subtract 2 from the left. So 6 minus 2 is equal to 4. And this is equal to a over 4. So now let's multiply both sides of the equation by 4. So we get 4 times 4 is equal to a over 4 times 4. 4 cancels on the right side. 4 times 4 is equal to 16 on the left side. And we get a is equal to 16. All right, let's take a look at problem number 3. Number 3, we have 9x minus 7 is equal to minus 7. So let's add 7 to both sides of the equation. So we get 9x is equal to 0. Let's divide both sides by 9. So we get 9x times 1 over 9 is equal to 0 times 1 over 9. 9's cancel, so we get x is equal to 0 divided by 9, which is just equal to 0. Let's take a look at problem number 5. We have minus 4 is equal to r over 20 minus 5. So again, we'll add 5 to the right side of the equation, add 5 to the left side of the equation. We get negative 4 plus 5 is equal to 1, which is equal to r over 20, negative 5 plus 5. So now let's multiply both sides of this equation by 20. So then we get 1 times 20 on the left side of the equation, which is equal to 20. And then r divided by 20 times 20 is just equal to r on the right side of the equation. Let's take a look at problem number 7. So for number 7, we have v plus 9 divided by 3 is equal to 8. So the first thing let's do is let's multiply it by 3. So we get v plus 9 divided by 3 times 3 is equal to 8 times 3. 3's cancel on the left side. We get v plus 9 is equal to 24. We'll subtract 9 from both sides of the equation, and we get v is equal to 15. So again, the whole concept is trying to isolate the variable, and whatever we do to the left side of the equation, we have to do to the right side of the equation. Let's take a look at problem number 8. For number 8, we have 2 times n plus 5 is equal to minus 2. So again, we're going to go back and do the distributive property. So we get 2 times n and 2 times 5. This is equal to 2n plus 10 is going to be equal to minus 2. Now we didn't change anything on the left side of the equation, so we don't have to do anything to the right side because all we're doing is the distributive property. It doesn't change anything on the left side. So our next step here is going to be subtract 10 from both sides of the equation. That leaves us with 2n is equal to minus 12. Now let's divide by 2 on both sides of the equation. Bear with me here. Having some problems with my iPad over here. So we divide by 2 on both sides of the equation. 2n divided by 2. We just get n. And then minus 12 divided by 2. We get a minus 6. All right, let's jump on down and take a look at some volumes. So again, we touched on volumes in the previous hour, but this will be a good refresher. So find the volume of each figure, round your answer to the nearest tenth if necessary. So the first one we have is a cylinder. So let's jump back to our reference material and see if we can find an equation for volume of a cylinder. So volume of a cylinder is equal to 0.785 times our diameter squared times our height. So if I remember right, 0.785 times d squared is actually the area of a circle. So to find the volume of a cylinder, we're going to take the area of the circle on the bottom here. We're going to take that area, multiply it by our height, and that's going to give us our volume. So for this problem, volume is equal to 0.785 times our diameter, which is going to be 2 times our radius, squared, times our height. So order of operations, we're going to do 2 times 8 first. We'll square that. We'll multiply that by 7 and 0.785. And this is going to give us 1,406.7. Now, I'm in trouble because I did not track my units on this. My units are going to be kilometers squared times kilometers, which will give me a kilometers cubed. Let's jump down and take a look at one of the word problems. So again, we're trying to find the volume of a cylinder with a radius of 4 yards and a height of 5 yards. So one thing that might be helpful in some problems is to actually draw it out. It all just depends on how you guys think. But we have a cylinder again with a radius of 4. And a height of 5. So going back to our equation for volume of a cylinder, we get volume is equal to 0.785 times our diameter squared, which is going to be 4 times 2, times our height, which is 5. This is going to give us, so we'll do our 2 times 4 first, we'll square that, and then multiply it by 5 and 0.785. We get 251.2 cubic yards. So let's look at problem number 12. Find the volume of a square prism measuring 6 kilometers along each edge of the base and 5 kilometers tall. Now you have to forgive me here because I cannot draw a square prism. But we know that we have 6 kilometers along each base. Bear with me here. And the height of it is going to be 5 kilometers. So let's jump over and take a look at our cheat sheet. And we have the volume of a rectangular tank which is what we have here. It's going to be volume is equal to length times the width times the height. So our length is going to be 6 kilometers times our height, or our width, excuse me, of 6 kilometers times our height of 5 kilometers. So 6 times 6 times 5 is going to equal 180 cubic kilometers. So again, if we look at this, the equation for the volume of a rectangular tank is going to be the area of the bottom times the height of the tank. Same thing that we had with the cylinder, which was area of the bottom of the cylinder times the height of the cylinder. So with that, that's going to wrap up the end of our second hour of Math 1 and 2. If you're joining me next, we're going to have the third hour of Math 1 and 2, where we're going to dive into some more example problems. They're going to be a lot more interesting. They're going to be more directly related to the types of problems you guys encounter as operators. So I look forward to, well, I won't see you guys, but you'll see me. All right, bye.